Okay, we should be recording. If anyone has any questions on Zoom, just let me know audibly because I won't be looking at the chat. But for the first one, we'll be taking a look at, there's 3 new plugins today. So IntraLattice, Crystallon, the SkeletonFattener, and then the Parakeet plugin. We'll only be touching on like a couple components from each of the plugins, but each of them have a lot going on that we probably won't even look at most of it during this semester. So the first one here, we'll be taking a look at the kind of white and gray group, so like the middle group first, and building out this kind of shirt mesh piece. So yeah, basically what we'll be doing, and we've kind of done similar things in the past. So we're taking a look at surfaces again, UV mapping on a surface, and then pattern generation on that UV mapped surface. So once we do that, we'll use some of the other plugins. So they're all pretty much right here. So if I turn on this, we can see. So we can basically put a very simple pattern on top of a surface. So in this case, we just have some diamond panels from the Lunchbox plugin that we used before. With the Crystallon plugin, we have this component where we're able to merge curve systems together based on a max distance tolerance number. So it'll basically take any curves that are within a tolerance and combine them together. So we're taking kind of this spiral that's all separated and then pulling them together at locations where the curves get within this number of 17 in my case. IntraLattice just used to clean up and create, I could see what this bar says, to create some lattice structures as well. So any of the people looking at lattices for their final project, this might be nice to work with. I don't know if this is the full plugin. I might have messed up on this, but I know there is a plugin that deals a lot with lattices, so it might be a nice one to look at. Mesh Fattener. So we've looked a lot at Dendro in the first half of this course, using Dendro to take curve systems and thicken them into something we can 3D print. Mesh Fattener does pretty much the same thing, but a lot faster and just with this one component. So that's kind of the pros. The cons are we don't have as much control over the final shape as we do with Dendro, where we can really tweak the whole volume itself. But this one will take a curve system and thicken it based on these number values. And then using Weaverbird, we've used this one in the past, we can smooth out that kind of rough mesh with few polygons into something with a lot more polygons, much smoother, and create the final thing like that. So that's the first one we'll look at today. So we'll go ahead and get started with that one. So again, we're kind of using that middle section group to start with. So with this one, we have a couple inputs here that I've given you all. So the first one is the figure itself. So we have a low poly figure. I think we've used this one in the past as well. We have these 2 surfaces that define the start and the end of the top / shirt that we're making. And then I've also given you this kind of snippet of the figure itself. So we can use this as a more simplified piece of geometry that we can do the curve system mapping onto. So we don't use the entire body itself and kind of get confused, around weird parts like the fingers or the legs or something. We don't need those, so I took them out and we'll just stick with this. Okay, so with this, the first thing we'll do is we want to take, this is a mesh. If we hover over, we can see it's a mesh with 652 faces. We want to be able to map a pattern onto kind of the torso region right here. So if you remember when we worked with patterns before, we got the patterns from the Lunchbox plugin, which is one of these. So with these patterns, if we take a look at the inputs, we see that the only inputs we have are surface and then the U and V values. So a mesh is not a surface, as the name implies. So we'll have to do something first to convert the mesh to a surface where we can then apply the pattern onto. And this is also a cool workflow, at least this first part, for converting things to surfaces, because it's usually something that might be quite necessary if you want to do any mapping, but is quite difficult if you don't know how to go about it. So the method I'm about to show gives you a generalized interpretation of the mesh. It's not perfect, but it's pretty close. So we'll go ahead and get started with this process of converting it to a surface. So the first thing we'll do is with these two surfaces, and we're basically going to cut the mesh up into a lot of different layers, and then we can basically loft all those layers together to get a surface. So the more layers we have, the more detailed the loft is going to be, but it also takes longer to compute. So it's kind of a balance between detail and speed here. So the first thing we can do to get more surfaces in between the mesh so that we can get these kind of mesh intersection curves is to tween consecutive surfaces. So, and this is a long one, so I have too many ends. Yeah, so right here, tween consecutive surfaces. This is a pufferfish component, so you could also maybe find it that way, going to pufferfish surfaces and then finding this component, or you could also type in the very long title. And there's a lot of tweening surfaces components in pufferfish. There's probably like 10 with very similar names and similar functions, but we'll want to do the consecutive surfaces with an S, so we can pass it between multiple surfaces. So if you grab that one, we should have a bunch of inputs on the front here. We're only going to be using 2 of them. So we'll use these first 2 inputs to control what this tween consecutive surface component does. So with the tween consecutive surfaces, what this component needs is surfaces. Basically, we have those. And then also this factor value. So the factor itself, I'll put these 2 surfaces into S here so we can start to see what will happen. So right here, we can see the surfaces. These are the inputs. And right now, the factor value is at 0.5. So if you remember when we worked with curves before, we could do a thing called reparameterizing a curve, where the curve can be any length, but we can reparameterize it and basically get it to start at a value of 0 and go through the domain up to a value of 1 at the end. So basically, this factor is doing the same thing. These 2 surfaces, we could think of them as the start surface and the end surface. And this factor of 0.5 is giving us a plane right in the middle of those 2. So right there, we have 3 surfaces, but we can add a lot more. And with this range component that I've given you, I've created 21 numbers that go between 0 and 1. So basically, the range has a domain of 0 to 1, and we've given it 20 steps to go in between. So if we plug this into the factor instead of the 0.5, we should get 20, 21 frames in between those 2 surfaces. And as well, so the factor also has 0 and 1 in the list. So we have kept the original planes as well, because 0 will be the start plane and 1 will be the end plane. So right now we have all of those 21 untrimmed surfaces. So the next thing we can do is, using this mesh torso itself, we can find the curve intersection between the planes and the mesh and get those curves. So pretty easy. The component for this one, the acronym for it is MMX, so the mesh intersection. So you can type that in, or you just type MMX and that should pop up for you. So with this, it needs 2 meshes. So we have one mesh, which is the torso, but we also have these untrimmed surfaces as the planes. So we could first convert the planes to a mesh before plugging them in, or the mesh intersection component will do it for us. So we can just plug in these surfaces to one of the inputs, and then the mesh torso to the other input. Okay. How long does that take? It's funny. I did this at home on my other computer. It takes like 2 seconds, and this one takes a little bit. But there we go. We got the curves to come in.
Yeah.
And I just need Grasshopper to come back now. If I can force it. There we go. Okay. Okay, so right now we have all those curves that start at the top plane, go to the bottom. So what we can do now is loft all of these curves together, and that'll give us a surface going through all these curves. So we could add more numbers here, which will give us more curves, which will make the final result more accurate to the input mesh. Or we could do less curves. It'll take less time to compute, but the kind of output will be less exact. So right now we'll just stick with 20. I'm not going to change that. So before we go to the actual lofting step, there's a couple things we'll do to clean up these curves before we actually loft them to maybe save ourselves some time on the actual loft. So the first thing we want to look for is to make sure that all these curves are closed, because when we're doing the loft, we want to go through curves that are all pretty much the same kind of curve. So we can't go from a closed curve to an open curve and then back to a closed. The loft will just not compute at that point. So right now with the inputs I gave you, I made sure that that's not going to happen. So we have this kind of closed torso where the arms are not holes and the neck is not a hole. So I made it like a solid mesh. So we don't have any issues of the curves themselves being open and some being closed. So that's already fine. So we don't have to worry about that. But we will do first is to rebuild the curves, which this is another pufferfish component. Just rebuild curves. Actually, I think it is. Yeah.
The grasshopper itself doesn't.
Grasshopper does have one, but I'm using this for, it has a couple more inputs than the grasshopper specific one.
Oh. Okay. Similar to the ones in Rhino.
Yeah, so because we also have this one. Curve degree count.
Yeah.
I mean, we could probably use either, but I don't know. I had this one in my workflow. So yeah, I guess just to see what other plugins have available. So we'll plug the curves into the C component, and we'll also flatten them as they come in, just to make everything a little bit easier for us. So in doing that, we'll want to make sure all these curves have, and it's hard to see, but we'll want to make sure they all have the same number of control points within them and the same degree as well. So that way we make sure the curves are very, very similar going into the loft. So for the degree itself, you have a couple options for degree, basically 1, 2, or 3, but we'll stick with 3 for right now. So I'll just grab a panel. You could also grab a slider for 3 as long as you get the number 3 in. We'll just give that to the domain or the degree, sorry. And then for the point count, we can use another panel. And I've just gone with the number 50 for this panel into the count. So now this makes sure that each of these curves, no matter what their length, all have 50 points. Because when we do the loft itself, the loft can be finicky if we don't clean it up first. So we're basically lofting kind of the points or the segments of the curves to the next one. So we want to make sure they have an equal number of kind of segments and points to go in between. So with that, the next thing we want to do to clean these up is to make sure that each of the curves are going in the same direction. Another thing that's pretty much impossible to see in Rhino is what direction the curves go in. But basically every curve has a start and an end point, even if it's closed. So all these curves are closed, but they do have start and end points. And each of those start points, correspond to where it starts, and then the domain of the curve. So, we did the factor for the planes, but curves also have a domain from 0 to 1. So the start goes around to the endpoint, and then the domain goes from 0 to 1. So if we have a curve that's flipped, it'll go the opposite direction. And when we try to do the loft, we'll see the loft kind of do like a 360 as it tries to go to the next curve. And that is really awful for what we're trying to do. And we want a very solid standard flow going between the curves. So in order to do that, there's a nice component that comes with Grasshopper called just flip curve. And what this component does is it takes in the first input a curve list, and in the second input a guide curve. So we can define one of our curves in this list to be the guide curve, and basically that curve, whatever its direction and domain is, that'll get mapped correspondingly to all the other curves in the list. So they should all flow in the same direction. So we can plug the curves into C as they come in. And then if we look at G here, we'll need to set an optional guide curve. In our case, it doesn't matter what the curve is or what direction they're going, as long as they're all going in the same direction. So pretty simply, we can take a list item. And what this one does by default, if we plug the curve system into L, is it'll just take the curve at the index of 0. So the first curve in our list. So right now it's just taking the curve in the bottom, and we'll use that as the guide curve to map the directionality onto the rest of them. So once we have this single curve selected, we can just plug that into the G for guide, and all the curves should be flowing in the same direction now. So the last thing to do is to make sure the curve seams are all aligned. So we have a pretty clean kind of start and end, or a seam on the actual loft itself. In order to do that, there's a nice plugin in Pufferfish just called Align Curve Seams. And I spelled that wrong. How did I spell it wrong? I don't think I did, but that doesn't look great. Oh, okay, that makes more sense. Okay, so right here, this one. So it looks like 3 concentric circles with some points in line. So align curve seams. So with this one, it doesn't need any inputs other than the curves themselves. One thing we can look at before we plug this in is there's a nice component that comes with Grasshopper itself called endpoints, and we can use this to kind of see where the start and end points of curves are. So in this case, at least in mine, the start and end points that it's pulling up are all very random, kind of on the right side of the figure, but still not aligned with each other. So if we take a look at the curves after they've gone through the aligned curve seams, we can now see that we have a very consistent start and end for all the curves. Right now it's going down the middle of the figure for me, but it could be anywhere else on yours. It just doesn't matter as long as they look visually aligned. Yeah.
It's like, I do have the points on the front, but there's also points to the back.
Yeah, I mean, I'm assuming you just have the other things previewed on, possibly.
Oh,
Like the components before it.
so that's the start and end.
Yeah, that's the original start and end.
And this is after we align
Yep.
it.
Yep. Yeah, so at this point we can do I'm just gonna get rid of this one. We can grab the loft component at this point, and we'll begin to loft these all together. So the one thing we do before we want to plug the curves in is there's another component that we can use called loft options. So it's kind of the settings for the loft itself. So we can define how the loft is going to look before we actually plug the curves in. So we have a couple inputs here. The first one is closed loft. In our case, we don't need a closed surface. We want to have an open surface so we can map the pattern to it. So we can leave this as false. The next one, adjust seams. So this one is pretty nice. I always turn this one on just to be safe. So we can grab a Boolean toggle and plug that into adjust and just set that to true. And what this one is doing is basically doing all the steps we just did. So, flipping the curves and aligning the seams to make sure it flows as nicely as possible. The only reason we built this all out is to ensure that we have the cleanest input data that we can build. So the rest of them rebuild. So we could add a value to this, so 0 to a high number. We can change that, and that'll kind of just make the loft kind of be less precise to the input data. So if you have really messy input, you could rebuild it and get like a smoother loft. We could also refit it, which is very similar to rebuilding. Or we could do a type. So the type is also nice sometimes to use. It has just a couple options. So normal, straight, uniform, loose, tight, kind of all just different preferences you can do with the loft. But right now we'll just leave it at 0, which is normal. So it'll just use the input curves as they come and do a loft in between. If we did something like straight, then we would have very hard changes between the segments as they go from surface to surface. So you would see kind of a hard cut between them. With normal, it'll be a smooth transition between them, basically. But there's 5 other options that do different things. So we'll plug that into the O, which is the options input here, which will get that set up. And then we can plug the adjusted curves coming out of A into C for the loft. And it should, after a couple seconds, give us a nice loft.
I'm assuming some of the curves are open.
Oh, it does say some of them are open. After the align curve seems one. Interesting. So yeah, what we can do to fix that, there is a component called just close curve or closed. Well, no, actually not that one. This one is a test. Yeah, so we could be smart about it, or we could just brute force it. So if you wanted to brute force it, you could plug the curves into close curve, and it will close everything, but it'll also give you an error if you already have some closed curves, and it says if it's already closed, you can't do it again, which is fine. It'll close the ones that aren't. The other option is we could check to see if they're closed first, which will give us a true false value, and then we could like sort the list by the Boolean and only use the ones that are open. But that requires, a little bit more workflow to do that. We could just plug it into curve and it should work. So let me know if the loft is being able to be closed.
Saying if the curve is linear, it can't be closed.
So you just have a straight line somewhere. That's interesting. Yeah, it could be very small. How many curves do you have coming out of A, I guess, in the align curve seams?
26.
26. Okay. Yeah, I just have 21. So you probably have some really, really tiny ones somewhere in there. You probably can't see too well. Yeah, Nick, what you could do, since I'm assuming they're probably like very, very, very minute, they're probably just 2 points, which is why it's making a line. Is you could test the length of all the curves and say like, if the length of the curve is smaller than something small, I don't know, like 1, then we could get the true falses, and the ones that are, let me see, I think it's false. Yeah, so if we set it up like this, all the ones that are true would be the ones that are like super small, and hopefully we see 5 trues.
Right.
And if that's the case, then that would fix it, and we can just delete the ones that are too small. Is anyone else having an issue like this? Yeah. And everyone was using the input of just the torso itself, right? Not the whole figure. Okay. Yeah, because I tested this earlier and ran into that issue, but I fixed the input mesh, so we'd hopefully not do that. But yeah, Nick, let me know if you get some trues, and if that works, then we'll just go forward with that.
Is there a component I can use to find open curve?
Yeah, so if you just grab the closed, like with the D at the end,
Okay.
it'll say like if it's closed or not.
So,
So
and then
Yeah, so if closed is true, then it is closed. If
Oh,
it's,
there's one false. Is that what it-
looks like it.
Cause it's 21, but then it's still.
You do have
has-
21?
Yeah,
yeah.
I do have 21, but it still say there's an open one.
Mhm.
Yeah, I've got 5 true ones.
Okay.
So it should be it.
So, okay, then this will work. So I guess for in the back of the room as well, this part should probably work for you too. Hopefully, if you have the same issue. So yeah, Nick, once we have this, we can use a component called col pattern. So with the true false values, we have a pattern here. So true, false, 0, 1. So we can plug this top output into the pattern input, and then just plug the curves themselves that we used to grab the length into the list. And then you should have 21 coming out at the end here. I have nothing because all mine are closed, so.
Or I've got the 5 coming out.
Oh. Okay, yeah, so little quirk there. So if you right click on the P, in this case, since this is Boolean input, we have this extra little button down here called invert. So we can just flip that Boolean value and you should go from 5 to 21. Yeah.
So I identified one false is the same.
Right, yeah, so we can do that one as well, which is also pretty simple, just a couple components. So yeah, for Susan, she has one open curve. So I mean, it would probably work just with the
It does,
closed.
it did work.
You're just brute forcing it, but if you want to actually like be smart about it and like know which one is which. Yeah, so we can use the closed component, which will again give us the Boolean list, and then we can use this col pattern component. Same thing. So we'll just use the pattern from if it's closed or not into P, and then the curves themselves into L. Just flip the Boolean input, and then this should give us. Well, actually, in my case, it's giving me none. So if I had one that wasn't closed, it should give that one to me. Yep, so plug the closed into the pattern part. Yep. And then the list will just be the curves themselves. And then what do you have coming out?
First one. This one?
Well, I think it's lighting up in green, the one it's giving you.
Oh,
Yeah, so we'll just flip that pattern input. So if you just right click on the pattern input,
Oh,
yep. Invert it. And we get that one curve. If you click on it, yep. And then we can just plug that into the one that closes it. Yeah. Yeah, so once you do that, you should just have one curve in the closed curve, like the closed output. And you'll have to just insert that back into the list itself. So you can get them all as one again. Because if we just use that curve, then we just have a single curve. So in order to do that, I guess this is a little bit more components than with Nick's solution. But we can just use an insert component and then insert items. So the original curves themselves will be the list at the top that we'll act on. So yep. So we'll act on this list. We'll want to insert the curves that you just closed. So that'll be L. And then all we need is the index itself. So right now in the col pattern, you have a pattern there if you can hover over it, just the output. Yeah, so we have the pattern, and right now it's planar curve. Oh wait, never mind. So go to the closed component, that gives you the entire pattern. So with this one, what we can do to find the index of the opened one is there's a component called member index, which comes with Grasshopper. So with this one, what we can do is we can plug in the Boolean list into S. So this is kind of the set that we're going to search for. And then we want to search for, what's the one thing is it false is the value that's different in the closed list?
Yeah, it's in the closed.
So false is the one we're looking for. So we can just grab a Boolean toggle. And if we set that to false and plug that into M, then what this M index will do is it'll find the actual index of every single false value. So if you hover over index on the output, so we
Oh, is
get
that- yeah,
that number.
yeah.
So we'll plug that number into I on the insert list.
On the that's the index.
Yep. So what we're doing is basically flipping out the bad one with the good one
The good
that we
ones.
fixed.
Okay, so this thing.
And now you should have the
Flipping.
final list. Everything should be closed. So
Ah,
that's
okay.
kind of the smarter way to do it,
Mhm.
rather than just
And then
brute forcing
plug
it,
this
getting there.
into
Into the loft, you should be good, yeah.
And the last step to fix one curve.
Yeah, but I guess think about it, if you had like 10,000 curves. And you were
Oh.
like, oh, I have, 500 open ones, this is a little bit as a cleaner way to do that.
Okay, it's red.
Hmm?
Log overload. Why is it open?
Yeah, hover over your output list, or maybe you can test that for close again, but. Oh, there's a planar. Well, that should matter.
Planar, what is a planar? curve?
Just a curve that's completely flat.
Oh,
That's not an issue. Shouldn't be. And how many curves you have coming out on the list?
22. And now that's one more.
Oh, well, maybe you have the same issue that Nick was having with a really short curve
Oh, yeah.
somewhere hiding in there.
That do both.
Yeah, so yeah, I'm gonna put this, what I have so far, in the Discord so everyone can see it. And work with that. Why am I on the Discord? Okay, so
Okay.
yeah, Susan, I'll put the
Yeah,
file
yeah,
in there and then you
yeah,
can take a look at it.
I have to read it or.
Okay.
I didn't have that problem earlier. After
Mhm.
this, now the problem. is up.
Yeah, it's interesting. Okay, it's the same name as before, but that one has some more stuff in it. Okay, so we'll continue to move on. We don't need any of this. We just need the loft down below. Let me turn all this off. Okay, so. Yeah, once we have the loft itself, yeah, back to the original workflow. Where'd I go? Okay, so we'll see that we do have this really nice seam going right down the middle of the torso. So we have a pretty clean loft. And now what we've done is we've converted that original mesh to this untrimmed surface. So now with the surface, we can actually apply a pattern onto it. So we'll start with the diamond pattern component that I had out earlier. So I'll just grab it again. So diamond panels from the Lunchbox plugin, these little blue diamond shapes. Oh, Soren, thanks for the image you put in there. Really cool. We can talk later if you want to go over some of that. Okay, so with this surface, what we can do is we can just plug the the untrimmed surface into the surface input for the diamond. Right now, we have a very, very basic textured surface on here because we only have 10 divisions in both U and V. So we can make these numbers a lot higher. I'm just going to make a slider between 20 and 100. So we have some numbers to play with. And I'll just use 2 of them. So just 2 sliders from 20 to 100. You can do whatever, that's just a safe range for me, so I don't crash anything. And I'll just plug those both into U and V.
Right.
So coming out of the loft, if you hover over L, does it say untrimmed surface? Or hover over loft.
One locally defined value open VREF.
Open VREF. Yeah, so yeah, you'll need a surface, not a VREF, for this to work. In the loft options, You didn't close it at all, did you?
No, I don't.
Yeah, because the close should be false. If you close it, it might give you a B-rep sometimes. But
It doesn't look close.
no, it doesn't look close. What are the errors on those orange components?
Close, open curve. This one says the curve is already close to not even again.
Okay, that's not a big
This
issue.
one says. Curve set includes open curves is not. And it's the open curves. Have a seems to be like interesting.
Interesting. That might be giving you the issue if you flip those two. So if you put the closed after the flip and then the align after the close, maybe that'll solve some of the errors. Yeah, so do close first and then align. That might help. Store it on the table.
The close curve says. The curve is already close to my.
Yeah.
Just take it out.
Yeah, maybe you could try it without it. Just see what happens. Yeah, it's funny that we all have the exact same inputs, but get wildly different outputs during these classes.
I'll just download the.
Oh yeah, you might try that, because that should clean up all those errors on the components and hopefully that works for you. But yeah, in the meantime, we'll keep going with the workflow. So we have the diamond panels, and at this point with the panels, you can make them as dense as you want in the U or the V. Right now, just keep it simple, maybe bump it up later as we get the rest of the workflow down. But at this point, what we'll want to do is just remove, or I guess select some of the edges so we can get that spiral going around the shape. And if we still have bend, I mean, this might go towards kind of the wrist arm brace as well. So
Yeah, I was thinking the same thing. This is
yeah,
pretty cool.
so we'll just grab a deconstruct B-rep. And what this will do is it gives us some outputs of faces, edges, and vertices. The edges is what we're looking for at this point. So if we connect up the diamonds to the B-rep, it'll show us everything in Rhino, but we'll only need the edges at this point. So, is there a question?
I downloaded this file and then it gave me an error at the top.
Yeah, I didn't plug in any of my fixes to the rest of the script.
Okay.
They're kind of just floating up there. So you could probably do the, which one? The delete short curves first. Pipe those into the close curve. So like pipe all that in, and then use this one as the final closed curve for the loft. Okay, so with the deconstruct B-rep, yeah, we have the edges, so we'll use that and we'll just plug those into a list item. Oh, can't type.
Which plugin is Diamond from?
So that's from the Lunchbox plugin. Where do I put everything? I think we've used this one before, so it's probably up in announcements. Yeah, right here. Yeah, you can still see it. From February 21st, there's a link for the Lunchbox plugin. Okay, so with this deconstruct B-rep, we can take the output from the edges and plug those straight into the list for the list item. And right now, currently with each of the diamond cells, you know, take this kind of cell right here as one diamond. Each diamond has 4 edge curves. And with this list item, with the index set to 0 by default, it's just going to take the first edge of that diamond, and it's going to do it for every single one. So, you know, this might be what you're looking for. In our case, I did something different for the index itself. So what I did is I used two numbers. So first one, I'll grab a panel of 1 and another panel of 2. So I also grabbed an addition component, so you can search for that just by typing the plus sign, grab the addition, and we'll be adding these two together. So with this, we'll plug the number 1 into the index for list item. So this will kind of change your output a little bit, switching from 0 to 1. And we'll also plug in the solution for the addition into the same input. So if you remember from the past, we can grab the output from A plus B. And while holding shift on the keyboard, we can plug that into the same input as number 1. So by holding shift, we get that little green arrow. And if we let go on the mouse, we should get them both going into the same input right there. So we have 1 and 3 coming in right now. Is it working over there with the?
No, it's.
So the loft is just completely not working at that point.
So we plug, so it's a whole.
How many
That
do you have
should be-
coming out? How many curves do you have coming out?
23.
So you have
22.
So you have 23
23.
total.
Same. Oh. Yeah.
Well,
I got it.
okay. I wonder if the number over there, number 1, is too small. I don't know how long the curves are. Like if you hover over the length, you can get a gist of, what an average curve length is. If you hover over the output right there. So you got some pretty big numbers. So you could, I don't know. Yes, you're all pretty big.
So that's.
So you could probably increase that 1 to like 100 or something and see if that removes more curves. Because we want the output of the whole pattern to be 21,
Yeah.
because we had 21 input curves.
Oh, that's one.
Okay, so try the output of the next one. Is that also? Still says 23 over there.
Yeah, if you just take this
Oh.
one and connect it there, it should be.
So
Oh,
also, so this input's also still going up here. So we want this to be the new input for everything up there. Now, hopefully we should have. That's funny because you have 21 going in.
Yeah.
I don't think you have 23 going out.
And moving on 20.
But yeah, if closing the curve works, then just go with that. Okay, I'll come back in a couple
That
minutes.
works.
Oh, good, good.
So
Okay.
there isn't actually like, it just need to close on, you need to delete the short one. And
Right.
then once it's deleted.
Yeah,
The short one is the one that's like, too short.
probably, yeah,
Yeah.
so. Okay, good to know that works. Okay, so yeah, back to the workflow. So at this point, we now have this kind of spiral shape going up, and you could put in whatever indexes you want. You have between 0, 1, 2, and 3 to do. Right now, I'm just doing 1 and 3. So we get this kind of pattern, but you could choose something else. So once we have this, we'll just go ahead and flatten the output here. So we have all the curves within the same list, because the next thing we'll do is use the Crystallon plugin to kind of merge all these curves together. Okay, so,
Running.
oh, it's running, yeah. For some reason on my computer, however I installed the plugin, I can't actually search for this component, so I always just copy it every time, but this is the name of it. You should see Crystallon up in the top, and you can see all of the components there. But yeah, this is the component we want. So the merge curves from the Crystallon plugin.
It's still coming out as beer.
There's another loft you could try. So what's it called?
Wait, there's like hash.
No, I wouldn't go with hash. No, it's so annoying. You could try fit loft, maybe. Oh wait, maybe not. What is it? It's an interesting one. Oh, this one. You could try unsplit loft. That might give you something better. Yeah, so it's the same thing. You just don't have loft options. So just set close to false again and keep the type at 0 and maybe try that. See if it gives you a surface. Yeah, just leave it how it is and just plug the curves in, basically. Okay, so what do you get out of that?
Oh, we should check.
Weird. Okay. Is anyone not able to see the Crystallon V2 merge curves component? Or you all got it? You had an issue with it? You just don't see it anywhere, or?
Yeah, I can find it.
Okay. Up at the top here, do you have a Crystallon like title?
Mhm.
You do?
No.
Oh, you don't see it. You might not have installed the plugin or unblocked it correctly. I can put this file, I'll just save it again and put it back in the Discord, and you can, if it comes up for you, then you have it installed. If not, then you'll have to go back and install it. But you might have the same issue that I had, so we'll just see if that's the case. Okay, so just download this one that I put in file sharing, this last one. And if it's there for you, then you have the same issue I do.
Merge curves.
Yeah, okay, so with this one, before we plug the curves into lattice, first we'll define max distance. Right now it has nothing, so I don't think it'll actually do anything, but just to make sure it doesn't like crash your computer, I'll just make a slider from like try like 5 to 20. I'm just gonna set it at 17 is what I have currently that I know works. So we can plug that into the distance value there, and then putting the curves into the lattice input. You should see this come up, and then yeah, right now mine is not affecting it because the curves themselves are pretty far apart. So what I'm going to do is just change some of these values over here to add some more diamonds into the mix here. So I'm going to set it U to 100 and V to 30. So that should give us a lot more curves. You could also just increase the value in the max distance slider a lot more until you see something happening. But right now with those numbers in, I see the curves being combined together in this more cell-like pattern.
Every time I like move the slider, it's a bad idea.
Oh. Yeah, my numbers of 130 might be a lot for some computers. I mean, overall, mine took about 2 seconds to load, but
Do you have 100?
130. Yep.
I do it the other way.
Okay, yes, it's good. Yeah.
Follow the recording.
Yeah. Okay, so was everyone able to get to the step of having the curves merge together with Crystallon or?
I have one with SkeletonFattener.
Okay. Okay. Okay, so at this point, there's only 3 components left for this one. So basically just thickening it and smoothing it out. So the first thing we do is with IntraLattice, we can just clean up the network. Basically just clean this lattice structure, make sure there's nothing overlapping or points that are too close together. So with this one, it will take the input curves and then just a tolerance to clean by. So right now, the tolerance that is usually pretty good for everything is just 0.01. And this will say, you know, if there's any curve or point too close to another one, it'll merge them together so we don't have any issues when we go to the final meshing step. Yeah, see you next week. So we shouldn't see any visual changes at this point, but we will see if we hover over lattice. We started with about 2,800 curves, and coming out we have about 1,700. So we took it down, you know, about by half. So basically what we did is with the merge curves, we might have had a lot of sections overlapping other sections, and this just took them out and cleaned everything up. So we have a lot lighter of an output here. So coming off this one, we'll use the SkeletonFattener component, which I believe is under mesh primitive. So we have this component right here.
Is
Could
it
also-
okay?
Yeah.
If I still have like 2,600 values?
Yeah, so I mean, everyone should have a different output. That's just what it looked like for mine.
Okay.
So yeah, it doesn't matter what number you have. It should work. We'll see in the next step for sure if it works or not.
Cool.
Yeah, so with the fatten component, there's a lot of inputs here. The main one to look at though is just the thickness value. So this will be kind of the offset distance from the curve to the kind of the radius of the actual mesh itself. So we can grab the value. I'm just going to do like basic 1 to 10 here, and we'll see if this is a big enough of a number to actually show anything when we plug it in. But this number can just go right into T for the thickness. And then we'll plug the curves or the struts now themselves into S for the skeleton list. And at this point, if everything's good, we should see a pretty clean, thickened pipe system around the curve list. And right now, this is a pretty nice way to work because there are some other components like pipe that come with Grasshopper. But if we were to try to pipe this many curves at once, it would probably crash your computer, if not take ages to finish. And the curves themselves would not actually be combined at all the nodes. Like with the fattener, they are all combined into a single mesh together. So we can make this thickness value anything we want to make those curves bigger. So once we have this, the last thing we can do to just clean it all up and make it look a little bit smoother is to grab the, with the Weaverbird plugin, the Weaverbird subdivision, which is kind of this red smoothed out triangle right here. So it's the Catmull-Clark subdivision method. And with this, if we plug the mesh output from the skeleton plugin to the mesh input from the Weaverbird, we'll go from kind of this rough pointy mesh to a much smoother mesh with a lot more polygons coming out. So now looking at them side by side, we've offset the original figure that we have and then created this generative patterned shirt around their torso. And we can change this pattern with, all of the sliders that we've set up already. The main ones being the sliders for the diamond. So we could make a more dense or more sparse pattern. And then with this max distance, we can change, how much all the curves are merged together. So how many cells we get and kind of how organic it is, or we can go a lot lower and see more of the original curve system there. So that is that whole workflow. Hopefully everyone was able to work through that as well. Yeah, this first part again can be really useful if you ever want to take any mesh you have and map a pattern onto it in the way that you could do with surfaces. But for the rest of today, since we are pretty close to 7, we don't have a lot of time to look at the other ones. The other ones themselves they didn't do anything that complex. It was just a good amount of components to get there. But I'll quickly show what was happening with those two, because we didn't get to take a look at the Parakeet plugin today. So I'll show one of those components. We have a component that can do a mesh growth algorithm on a mesh surface. So we can take a mesh itself and map a pattern onto it without having to convert it to a surface first, which is pretty nice. So coming in here, we had this, let's see. We had this, and this was a kind of an upper pattern for a shoe. So imagine the top of a shoe right here, kind of where the laces are. Were these two curves for this project. And for this one, it was a lot simpler than what we just did to get a pattern, only, about 10-15 components here. Basically what we're doing is actually taking it out of the VREP state into a mesh, because we can work with meshes with Parakeet. And setting, these are all just to see what face we start with for this pattern, but just to show what's happening here. We can start with this face on the original mesh, and with this block I haven't gone over yet, but it's called a trigger. It can basically update a grasshopper component with a certain interval, so you can set that interval here. And basically what it does is it'll just kind of start and stop this component, whichever one is connected to with this dotted line. And we can actually give it kind of a ping here, and every time we ping it, it'll update and grow this curve pattern around that shape. So we can see, similar to the physics-based stuff we were doing with Kangaroo last week, but in this sense, the plugin itself does it all with this one component. And we can see the curve system growing across, and using the same stuff as before, like with Weaverbird, we're able to thicken it with the mesh fatten and then smooth it out to get this pattern right here. And we're growing it and updating it with this data dam component, which is also nice. And this will update based on another interval. So right now we have 1 second. It'll compute, so we're not overloading our computer. We can see it grow to take up the whole mesh and just stop it with the trigger whenever we want and get that final surface there, that final pattern. So that's another way to add maybe a pattern to something that's not a surface, which is kind of a fun method also to watch it grow over time. But with Parakeet, there's a lot of stuff in this plugin, mostly for pattern generation. So it's really interesting one to take a look at, a lot more than we'll see in this class. And then the other one, so this one was just another crystalline kind of workflow, just with a different kind of curve system, but basically the same structure, just in a different way for the shoe upper. But again, mapping just another diamond pattern on the surface and using the thicken to grab some curves there. And we'll see where it's more dense, we have some more cells being formed with their closeness. And then where it's less dense, we have the original curves as well. So we get more of an organic shape with just, 5 components put together than what we were doing in the past weeks with Dendro and some other curve systems. So just another possibility there if you want to work with thickening curves and not using Dendro. Yeah, so that was everything I wanted to go over today. So yeah, for the people online and for the people in here, next week, we'll be looking at some more Grasshopper workflows. I forget what exactly. But if you want to bring in some updates on your final project, if you've made any next week, that'd be good to see. If you just have some more sketches or have started to make a Grasshopper workflow and want some feedback on it, or want some help with how to start a Grasshopper file, we can take a look at that in the beginning of next week, and then we'll move into a simple Grasshopper workflow up until 7 p.m. next week as well. So yeah, if anyone has questions, I'll be here for a little bit, but that was class today. So see you next week.
Yeah, RJ, I've got a question, and it might pertain to some other people as well.
Sure.
I think it'd be really helpful to learn how you got that original chest upper body piece that we used for any sort of body part. Especially like for me, like I would do like an arm or a leg, how you would go about getting that mesh that you had originally.
Yeah, just to offset it basically. Yeah, let me see. So yeah, like this one, right?
Yes. Yeah. Something
Yeah.
like that for an arm per se.
Yeah, so yeah, I did that before class today, but deleted the work. It wasn't a lot, so I can show it again quickly. So I guess for see you next week. For taking a piece out of the body, like if you're working on the arm, in this case, I have it set up for the torso. So just go ahead and look at that. But basically, and you probably wouldn't do it this way, but right now I'm just creating like a box, like a region around the area that I want to select out. So let's see what happens. Yeah, I'll just do it the other way. So I'm going to bake this into Rhino. So you probably start this way, like if you were to take a 3D scan of something.
Could I take one of my arm or something similar?
Yeah, so you could use the Polycam app that we looked at right before spring break. And that's pretty good. You can take a lot of photos of your arm and then get a 3D model based off of that and use that.
Okay.
So yeah, basically, once we bring it in here, we'll have that, and we can just set a box in the scene as well. I'm just going to make a simple box here. And maybe there's a way, you could automate this in Grasshopper, but at the most basic sense, we can just set it like this in Rhino. And then we'll just grab the mesh of the scan and the vref of the box that we made. And then I had used Dendro for this step. So I'm going to internalize it so I can just delete these out of Rhino. But they'll stay in Grasshopper. And it's pretty simple, just a couple components in Dendro. And we've set this up before, so I'm not going to explain it, but if we want to set up a time to talk later, we can kind of look at this as well. Okay, so basically what we can do is just convert both of these to a volume in Dendro, and then we can find the intersection, offset it, turn it back into a mesh, and you should be good to go.
Cool.
Earlier today. So right now they're both volumes. We can take the intersection of those two, which will just give us the arm itself that was inside the box. So just that part. And then we have a component within Dendro to offset based on, oh, this is smoothing. To offset based on a distance value, so we could plug in anything. I'll just, do 5 or something so we can see a little bit of change. Okay, so originally, yeah, we had this one.
Cool.
And then you could change this number, but this will basically
Right.
offset it. So once we offset it, we can just convert it back into a mesh. And you could, then plug this mesh into the rest of your script. Be able to go from there. So
Cool. So
Yeah.
what would I upload like a polycam scan as into Rhino?
yeah, so I think with the free version, I've been told last like 2 weeks ago that you can export as a GLB or a GLTF file.
Right, right.
You can take that into Blender and then just import it into Blender and export it as an STL.
Okay,
And then you can bring the STL into Rhino.
okay. So Rhino takes STLs. Perfect.
Yep. So that's pretty much the workflow I would do.
Cool. Thank you very much.
Yeah, you're welcome. Okay, questions?
Yeah.
Who's got a shorter question?
Mine's pretty short.
Yeah.
I just wanted to like set up another time. I sent you an email. I didn't want to be like over the top about it.
Yeah.
But whenever you have time, because I have questions about, well, the hat, if you want to talk about the weaving thing, and then also something about my thesis that's unrelated to this,
Okay,
whenever you have time.
yeah, yeah, I'll send you an email,
Yeah. that's-
either Thursday when I'm in the lab or maybe Friday.
Okay.
Yeah, that might work, so.
Alright.
Yeah, cool.
Appreciate it.
Yeah, so I missed the first part of class. I was up some- My alternator in my car is, I think, done for,
Yeah,
so it just like keeps killing.